Okay, welcome back, everybody. This is section 10.1, and today we're talking about the geometry of solids. So this section is going to have a ton of vocabulary in it. So get that writing hand ready. All right, we're going to start out by talking about polyhedrons. And all of these notes are actually copy and pasted right from our book, so they're very thorough. It says a solid formed by polygons that enclose a single region of space is called a polyhedron. The flat polygonal surfaces of a polyhedron are called its faces. Although a face of a polyhedron includes the polygon and its interior region, we identify the face by naming the polygon that encloses it. A segment where two faces intersect is called an edge. The point of intersection of three or more edges is called a vertex of the polyhedron. So as you can see, there are several vocabulary terms there, and I highly recommend sort of pausing, rewinding, going back, and taking these notes thoroughly. Now at the bottom, we have four polyhedrons, and you can see the pyramid that is our second figure right here. We have labeled the face, so the different faces would be the triangle here, right? A second one would be the triangular face here. And then obviously we have one in the back right and one in the back left. The edges are where those triangular faces meet, and you can see it designated there. And the vertex is where three segments meet. So each one of these polyhedrons would have faces, edges, and vertices. Just as a polygon is classified by its number of sides, a polyhedron is classified by its number of faces. The prefixes for polyhedrons are the same as they are for polygons, with one exception. A polyhedron with four faces is called a tetrahedron. Here are some examples down below. So first, over here on the left, we have the hexahedrons. Well, the prefix hexa means 6. So each one of those hexahedrons would have 6 faces. Now, if we take a look at this pyramid here, we can sort of count them. In the back, we have 1, another in the back, 2. Over here on the side, we have 3. In front, we have 4. And then over here, we have 5. And then don't forget the base on the bottom. That would be our 6th face. Right? Then we have the cube there, and you could count the 6 faces there as well. Now, down below here, we have the heptahedron. Right? So each one of these would have 7 different faces. Remember to count the base or bases. And then over here on the right, we have the decahedrons. So each one of these would have 10 different faces. Next, we're going to talk about prisms. A prism is a special type of polyhedron with 2 faces called bases that are congruent parallel polygons. The other faces of the polyhedron, called lateral faces, are parallelograms that connect the corresponding sides of the bases. The lateral faces meet to form the lateral edges. Each solid shown below is a prism. So the first one over here is the rectangular prism. The way that this rectangular prism is laying currently, we would have obviously the base on the bottom, 1, and the base on the top, 2. They are congruent rectangles. Next, we have the triangular prism. And this is called a triangular prism because the bases are triangles. You can see the triangular base here and the triangular base here. And then next we have the hexagonal prism. And it's called a hexagonal prism because its 2 bases are hexagons, 6-sided polygons. Now in this hexagonal prism, they're designating the bases on the top and the bottom. The lateral faces are the rectangles that connect the bases. And the lateral edges, the lateral edges are the segments where the lateral faces connect. Prisms are classified by their bases. For example, a prism with triangular bases is a triangular prism, and a prism with hexagonal bases is a hexagonal prism. A prism whose lateral faces are rectangles is called a right prism. You can see that the right pentagonal prism over here on the left. Its lateral edges are perpendicular to its bases. A prism that is not a right prism is called an oblique prism, and you can see the example over here on the right. The altitude of a prism is any perpendicular segment from one base to the plane of the other base. The length of an altitude is the height of the prism. So notice in the right pentagonal prism, the altitude, which is the height of the prism, is one of the lateral edges. But in the oblique triangular prism, the altitude actually falls outside of the prism. And that altitude is the height of the prism. Next, we're going to talk about pyramids. A pyramid is another special type of polyhedron. Pyramids have only one base. As in a prism, the other faces are called the lateral faces, and they meet to form the lateral edges. The common vertex of the lateral faces is the vertex of the pyramid. So let's look at the different examples. Over here on the left, we start with a triangular pyramid, and it's called a triangular pyramid because the base is a triangle. Next, we go to the square pyramid because the base is a square. Then we have the hexagonal pyramid where the base is a hexagon. And finally, we have the trapezoidal pyramid where the base is a trapezoid. Now, it's in this trapezoidal pyramid where they are actually showing us an oblique pyramid, right? Those lateral faces are not perpendicular to the base, right? And they're showing us the vertex at the top where the lateral faces meet, and they're identifying the lateral faces and lateral edges as well as the base. Now, at the bottom, a special note that the altitude of a pyramid is the perpendicular segment from its vertex to the plane of its base. The length of the altitude is the height of the pyramid. Now, looking at this right hexagonal pyramid, we see the altitude goes from the vertex and falls right down the middle to the base inside of the pyramid. However, if we have an oblique pyramid, that altitude may or may not fall inside of the pyramid. In this example, it would still fall inside of the pyramid, but notice it's not really out in the middle of the trapezoidal base, right? And if that oblique pyramid was even more exaggerated, that altitude could potentially fall outside of the base. All right, next we're going to talk about cylinders, and we've worked with cylinders already some. It says the cylinder has two circle bases that are both parallel and congruent. The segment connecting the centers of the bases is called the axis of the cylinder, and the radius of the cylinder is the radius of the base. If the axis of the cylinder is perpendicular to the bases, then the cylinder is a right cylinder. And we see that in the diagram on the left down here. A cylinder that is not a right cylinder is considered an oblique cylinder. And we see that on the right. The altitude of a cylinder is any perpendicular segment from the plane of one base to the plane of the other base. The height of the cylinder is the length of the altitude. So in the right cylinder on the left, the axis and the altitude would be the same. But in the oblique cylinder on the right, the axis you can see is not perpendicular to the base anymore. So the altitude actually falls outside of the cylinder, but is still perpendicular to the plane of the base. Next, we talk about cones. The base of a cone is a circle and its interior. The radius of a cone is the radius of the base. The vertex of a cone is the point that is the greatest perpendicular distance from the base. The altitude of a cone is the perpendicular segment from the vertex to the plane of the base. The length of the altitude is the height of the cone. If the line segment connecting the vertex of a cone with the center of its base is perpendicular to the base, then the cone is a right cone. Now there's a lot going on in that paragraph. If you look at the diagram on the left, we have a right cone, and they're designating the radius, the base, the altitude, and the vertex. The diagram on the right is an oblique cone. Now you can see that the altitude is falling outside of the actual cone. Finally, we talk about spheres. A sphere is a set of all points in space at a given distance from a given point. You can think of a sphere as a three-dimensional circle. A hemisphere is half of a sphere and its circular base. The circle that encloses the base of a hemisphere is called a great circle of the sphere. So the definition of a sphere is very important, and it's one that students often don't know. A set of all points in space at a given distance from a given point. The given point is the center of that sphere. Now the distance from that center to every single point on the sphere, right, on the sphere could happen here, but that sort of makes a circle. But there are also points here that would be on the sphere. So the distance to each one of those points is the same. Keep in mind the definition of a hemisphere includes the circular base of that hemisphere, shown here in the diagram. This will become important when calculating things like the surface area of a hemisphere. You'll want to be very careful when reading those types of problems to see whether or not the problem is including that great circular base or not. All right, so that ends the section. There's a lot of vocabulary there. It's very important that you take very good notes and be able to speak the language of geometry.